Good morning, calculus. This is the problem we're calling VBBC4. Obviously, this is a graph problem. So again, anytime you have a graph, first thing you should do is look and see what do I actually have a graph of. And this is a graph of F. And they just say it's consists of 3 line segments as shown here. So we have 3 line segments making up this graph F. Okay. Part A is talking about function g, and g is defined as the integral of f, so this is a function defined as an integral. So let g be the function given by g of x is the integral from -4 to x of f of t dt. For each of g of -1, g prime at -1, and g double prime at -1, find the value or state that it does not exist. Okay, so g at -1, again, literally just means plug in x is -1, so that's the integral from -4 to -1 of f of t dt. So I have f, and I'm looking for the integral of f. So how do I get an integral off a graph is area under the curve. So if I draw a line here at -4 to -1, I'm just finding the area of this, and I'm just going to make this a trapezoid. So that's going to be equal to 1/2. In a trapezoid, the bases are the parallel sides. This goes down 2 and this goes down 3. So the length of my bases are 2 and 3. And the height is the perpendicular distance between those bases, which is 1, 2, 3. And I could just leave my answer like that. Okay. No initial condition needed for this one, and they didn't give me an initial condition, so that's it for that one. All right, now for g prime at 1, well, g prime, so derivative g is g prime. The derivative of an integral is fundamental theorem of calculus. The derivative of the integral is just this function. We replace the dummy variable t with this variable expression up here, which is x. Chain rule applies, but derivative x is 1, so g prime at 1 is equal to f at 1. And this is a graph of f, so I just go to 1, read up to the graph, and f of 1 is equal to 2. So g prime at 1 is equal to 2. And now for g double prime at 1, that's equal to the derivative of this is, or derivative g prime is g double prime, derivative of f is just f prime at 1. And this is a graph of f, and I want f prime, so I need to take the derivative. How do I get a derivative off a graph? Is slope of the tangent line. Well, at 1, I can see right away this makes a sharp turn, so this does not exist. Now, it didn't say justify that. It just said find the value or state that it does not exist. So I can just write does not exist. If it wanted me to explain or justify that, I would have to say the derivative as x approaches 1 from the negative side of f prime is equal to whatever the slope of this line is, and that's not equal to the limit as x approaches 1 from the positive side of f prime, which would be equal to this. And since these two slopes are not equal, then that would be my justification for does not exist if they ask me to do that. All right, so that's it for part A. For part B, for the function g defined in part A, so I'm using this again, find the x-coordinate of each point of inflection. Well, it's my keyword or phrase. So point of inflection is a second derivative equals 0 or is undefined. And then you also have to change signs as well, because remember, by itself, these two don't mean anything, but f prime has to change signs. So and changes signs. On the interval -4 to 3, which covers the whole graph. So again, f double prime, I'm sorry, this should be g, point of inflection of g. So g double prime is equal to f prime, and I need the f prime to equal 0, so I'm looking for a slope of 0, which I don't have any slopes of 0 here. Or is undefined. Well, your undefined derivative, when it makes a sharp turn here, again, you don't ever write sharp turn, but it's easy to think that. So you do have g double prime or f prime, which is the same thing, has to change signs. So if I look at the slope here, this is a positive slope, and this is a positive slope as well. So this is not an actual point of inflection. Here I have a positive slope into a negative slope, so this is a point of inflection. So I would just write g has a point of inflection, or POI, at x equals 1, because f prime is undefined and changes signs like that. All right, for part C, now I have a function h. It's defined again as an integral, so h of x is equal to the integral from x to 3 of f of t dt. Well, what's different about this integral than this integral here? And I'll give you a second to think about that. So what's different here is the x is on the bottom, so I need to flip those over. So when I flip over the limits on an integral, that changes it to, in this case, a negative. So you change the sign, and that's the same as that. Okay. All right, so I'm looking for h of x to equal 0. Well, that just means plug in x is 0, so h at 0, I'm sorry, h of x equals 0 is when this integral is equal to 0. All right, which in this case is when this integral of f is equal to 0. Okay. Well, the first thing I know is the integral from the same thing to the same thing is always 0. So x equals 3 is one of the places. And again, that's going to be my starting point. So if I go 1, 2, 3, right here, the value of the function h, which again, this is a graph of f. So I'm not looking at the function h here. This is one place where we're equal to 0. Okay. Now, to go from h to this is the integral, which is the area under the curve. So the area under the curve has to be 0 as well, but this is like my starting point. So if I go backwards, I have the area of this triangle here, which looks like it's a base of 1 and a height of 2. So that's half of 1 times 2, or 1. And then if I continue backwards, this triangle also has an area of 1. So guess what? I'm going backwards, so this would be a positive 1 minus 1 would take me back to 0 again. So at x is 1, I'm also equal to 0. And then if I find the area of this triangle, that's 1, and this one's also 1. So guess what? This one would be negative 1, and then plus 1 would take me to 0 again at negative 1. And then from there on, I would just be, since I'm going backwards and it's underneath, I would just be adding this area, which is this up here. But again, there's nothing to cancel this out and go back to 0 again. So luckily they made it nice and easy because the areas of these triangles are pretty easy to determine, and it just visually looks like they're all the same. So all the values of x on the closed interval -4 to 3 for which this function h of x is equal to 0 would be x is -1, 1, and 3. And it just said find them. It didn't say justify or explain your answer. But when I did it, hopefully that made sense on explaining that. So integrals equal to 0, your starting point's always going to be the same thing to the same thing is equal to 0. Okay. And remember, we want this x to be on the top, so it looks like this one here. So if it's not on the top, or the variable expression's not on the top, it's not always going to be x. It could be x squared here or something like that. Just flip those signs and change the sign. In this case, you went from positive to negative. Okay, which is going to help me in part D as well. So the function h, again, defined in part C, which means I'm using this, find all intervals on which h is decreasing. So that's my keyword or phrase. H decreasing means h prime is less than 0. Okay. Up here I was just dealing with h, so I need h prime. So again, this is going to be fundamental theorem of calculus. The derivative of h is h prime, and the derivative of this integral is just the function. When I replace this dummy variable t, again with x, chain rule applies, but derivative of x is just 1. So h prime is equal to negative f of x, and that has to be less than 0. Okay. Well, guess what? With this negative here, f of x actually has to be a positive number because there's a negative in front, and a negative basically times a positive will give you a negative. And f is positive, well, when you're above the x-axis, which is from x is 0 to x is 2. So I would write h is decreasing on the interval 0 to 2 because either h prime, which is equal to negative f of x, is less than 0 on that. So good AB problem, but could also show up on the BC test as well. And again, especially this year, I would expect to see some graph problems like this where you have function defined as an integral, because this is not something that you can just look up. You'd actually have to understand what's going on. So definitely write this one out. keep it in your handy notes that you're going to use for the online test this year, because it's very likely that you'll see some problems like this involving a graph where they ask some of these things.